So today we're going to work on graphing inequalities. So if you look at the first page of the inequalities worksheet, we have this story. A man is asked to build some tables and chairs. Each chair costs $25 and will take 4 hours to build. Each table costs $60 and will take 6 hours to build. The man has determined he wants to spend less than 60 hours building these items, and his budget is at most 480. What are all possible combinations of tables and chairs that he can build given these limitations? So we're not too concerned about the intersection of these two lines. We're gonna make draw two lines on this graph, and the intersection is not the important thing. We just want to know how many combinations of tables and chairs can he build. Well, could he build one table and one chair? Yeah, he has plenty of money to do that. He's got plenty of time. Could he build 2 tables and 2 chairs? Yes. So the answer is actually a big range of different options of tables and chairs. He could build all tables, he could build all chairs, or some combination in the middle. So we're going to write down this information. So a chair costs $25, and it takes him 4 hours to build one. Tables cost $60, and they take 6 hours. How much time does he have? And be careful, what does it say? Less than or equal, or is it just less than? Less than 60. So the total time is less than 60 hours. What about his budget? At most 480. So how would we describe that? Less than or equal to $480. So we're going to have 2 equations here. One restriction deals with time and one restriction deals with money. So we need to choose our variables. What are we looking for? What are the unknowns? How many tables and how many chairs? And you could pick X to be tables or X to be chairs, it depends. Just so everybody does it the same way, whatever item is listed first, I want you to make that the X. Because otherwise your graph will be switched. Your X and Y axes will be switched. So we're going to say X equals something to do with chairs. What is it about the chairs? How many he builds. Not how long it takes or how much they're worth or anything like that. X is just the number of chairs. And Y is going to be the number of tables. Okay. So write an inequality dealing with hours. I know that he's going to have less than 60 hours. How many hours is he going to spend building chairs? Four hours per chair, but how many chairs is he going to build? It could be 0, it could be 1, it could be 2, it could be 3, we don't know. So how do we calculate the total number of hours spent working on chairs? Well, we defined X as being the number of chairs. We don't know what X is yet, so it's just going to be 4 times X. So 4X represents the total amount of time spent building chairs. Could X be 0? Yeah, he might not make any chairs. But X could represent a kind of a large domain of numbers. All right? How long is he going to spend building tables? 6 hours per table, so we're going to add 6y to that. Okay? So we're going to graph that line, and all possibilities, are they going to be above the line or below the line? Well, it says less than 60, so it's going to be below. And what kind of line is this? Does the line count? Why not? It's strictly less than, it doesn't have an equal to, so it's the equivalent of an open circle. How do you graph a line consisting of open circles? You just make a dotted line, and that tells us don't include the line. Okay? Write an inequality dealing with the cost of construction. So I know his budget is less than or equal to $480. How much is he going to spend building chairs? 25 times the number of chairs, which we defined as x. So it would be 25x plus 60y equals, or is less than or equal to 480. What kind of line is that? Solid line. Good. Okay, so I'm going to move those over. Get rid of this stuff. So if we go down to the graph, this graph is 15 by 15. For each of these equations, we could solve for y, but I don't want to. That's kind of a pain. Let me change the color for one of these. All right. So instead of solving for y, I'm just going to find the x-intercept and the y-intercept. What is the value of x on the y-axis? What is the x value here? 0. It's either 1, 0, 1, 0, 2, 0, 3. If you're on the y-axis, the x value is 0. So if I plug 0 in for x, if I cross this out, I'm left with 6y less than 60. I divide by 6, and y is 10. So I'm going to put a dot at y equals 10. Okay? Now I can do the same thing for the x value. It's at 10. 0, 10. If I cross out the y's, I'm left with 4x equals 60. What's 60 over 4? 15, and that's right at the end of the graph. And we decided this was a dotted line. Everything below that line represents a possible combination of tables and chairs that is less than 60 hours. So if you pick a dot underneath that line, that point represents a number of tables and chairs that would be less than 60 hours to build. Does that make sense? So if I were to look at the point 4, 2, is there enough time to build 4 tables and 2 chairs, or 4 chairs and 2 tables? Yes. If I were to look at the point 1, 12, is there enough time to build those? No, because they're above the line. What if I picked something on the line? 2, what would that be, 9? Is there enough time to build those? No, because they're on the line and the line doesn't count. That actually, it would probably be 3, 8. I think 3, 8 is the slope of that line is negative 2/3. So that's a bad example. But 3, 8, if I plug that in, that would be 12 hours building chairs, and 48 hours building tables. And there's not enough time, because if you hit 60, that breaks the rule. No. Okay. So, no. So now let's graph the blue equation. If I cover the x, y equals 48 divided by 6 is 8. So we'll go up on the y-axis to 8. Okay? And if I cross out the y, 480 divided by 25 is like 19.2. So 15, 16, 17, 18, 19.2. Solid or dotted line? Solid line. Okay. And which direction am I going to shade that one? Down. So I need to be below the red line and below the blue line. Okay? So, tell me, is this right? Why not? You can't make you don't get money back for putting chairs back in the box, right? This point over here would be 2 comma negative 3. Is there enough time to build 2 chairs and to put 3 chairs back in the box? That doesn't work. I mean, that doesn't make any sense. You can't unbuild a chair in this story. So when you draw the, in this case, when you draw the intersection of those 2 places, you have to stop at the x-axis and the y-axis. So as long as it's in that shaded area, that represents a correct combination of tables and chairs that satisfy both equations. If I pick the point 1, 8, why is 1, 8 not in the solution set? It's above the blue line, which means it costs too much. If you built 1 chair and 8 tables, that would be $25 plus $480 is over 5, I think it's 505. There's not enough money to build that amount. Likewise, if we came way over on this side and we did 14 comma 1, what's wrong with 14 comma 1? Not enough time. 14 times 4 is 56 plus $6 to build a table would be 62. There's not enough time to build that. Another thing you might want to consider is technically you could do half points, but they don't really make any sense. Why would you build half a chair or half a table? So really, only the whole number points count. Okay? All right, turn the page. So I'll read this one with you, and then I'll let you work on it for a minute. Fred wants to buy 2 different types of ice cream for a family outing. He has a very big family. He is looking at 2 types of ice cream. Type A costs $4.34 a carton, and Type B costs $6.25. All of the ice cream has to fit in one large cooler that can hold up to 14 cartons. If Fred must spend less than $75, what are the possible combinations of ice cream that will fit in the cooler? Okay, so I just want to talk about the 2 equations. So first we have a money equation. What is the restriction on the money? What about $75? So if we look at the problem, less than 75. So less than 75 will be one of our equations. What's the other restriction? Less than or equal to 14 cartons. Okay, so I'm going to pause the video. I'll let you guys come up with those equations and draw those graphs, and then we'll talk about it. So you should have come up with the equations 4.34x plus 6.25y is less than or equal to 75. I changed it to 3. So this will be the first one. We'll see how big they are. If they're too big, though, I can't. So we're trying. And what is the next one? What's the equation for the cartons? Just x cartons plus y cartons is less than or equal to 14. So when I graph this, I get a solid line from y equals 14 to x equals 14, and I'm going to shade below. What are the intercepts for the money equation? So 12 and 17 point something out here. And it's a dotted line. And then you're going to shade below that one. So that would be the intersection of those. So we could buy 1 carton of each, or There are lots of different possibilities. Yeah, if you want to, what's the cheapest way um, to fill up the cooler? This would be the cheapest way to fill the cooler. Okay. So what's no, the cooler doesn't have to be full. So this is a possibility, two of one and one of the other. It still fits the requirements. It fits in the cooler and it doesn't cost too much. So any one of these intersections actually works. Well, businesses do. You probably won't. I don't. I just buy what tastes good. Okay, turn the page again. Bjork is baking pies for Pi Day. Yeah, Scandinavian. No, Scandinavian. There must be at least 6 pies for the entire class. So how would we write that? Greater than or equal to 6. It's also estimated the class may eat as many as 15 pies. Less than or equal to 15. Those are two different graphs, but they both deal with the total number of pies. And then the last one says, Mr. White has also stipulated that more than half of the pies must be fruit pies. So let's call X fruit, and let's call Y cream. Yes. So how do we write an equation for that last stipulation? So if I did 2x and a single y, what's the symbol I would use? It's got to be greater than or less than. Yeah, between the two. No. Okay, let's try this again. I thought you guys might get that. We'll do it the other way. Okay. More than half of the pies must be fruit pies. So the number of fruit pies compares to the number of cream pies. So which one's bigger, fruit pies or cream pies? Fruit pies are bigger, so it needs to be like this. Is it equal to? No, because it says more than half, not more than or equal to. So now what do I do? So let's look at this. If I double the number of fruit pies, is that bigger than the number of cream pies? Is that what we were looking for? Think about that. If I take the number of fruit pies and times it by 2, is that what I want to compare to the number of cream pies? No. What do I want to do? You could either do x is greater than 2y or x over 2 is greater than y. But this one is incorrect because the number of fruit pies is bigger, more than double. So I need to double the cream pies to get caught up to the number of fruit pies, or I need to divide the number of fruit pies in half and compare that to the number of cream pies. Well, which one of those two equations is easier to graph? The y equals 1. So I want the y by itself. We don't know how to graph when the x is by itself. So my third requirement is going to be y is less than x over 2. The number of cream pies is less than the number of fruit pies divided by 2. Okay, what are the other two equations going to look like? That's not really there, sorry. What are the other two equations going to be? X plus y is greater than 6 or equal to 6, and x plus y is less than or equal to 15. So it's got to be above the 6 mark, below the 15 mark, and it needs to be underneath the y is less than 1/2 x mark. So you're trying to say that in the first equations you want 2x plus y is greater than 6? But it doesn't have to be. It could be 2 times or 3 times. It might even be 4 times. So we can't guarantee that it's twice as big. It's at least twice as big. So what Connor is saying is, why don't I times this by 2? Well, we have to have 3 separate stipulations. The first one is greater than 6. So we just want to know the x pi's plus the y pi's is greater than or equal to 6. We also know that that same equation is less than or equal to 15. But if you put that 2 in here, you're making an assumption that's untrue. Does it have to be twice as big? It could be 3 times as big, or 4 times as big, or 5 times, or maybe you don't buy any cream pies at all. So we want to leave that as a separate stipulation. So your graph is going to look like this. This is a really crude version. Here's the 15 line, here's the 6 line, and here's the 1/2 x line. Where would I shade that? So it's got to be above this, below that, and below this. So it's this little piece here. We'll just graph them like you did before. So just graph all 3 equations. Find the x-intercepts, find the y-intercepts. Yeah, 6 and 6 and 15 and 15. Okay, so there's one more problem you need to do. Finish that and then start working on the practice test, and we'll test. I don't know if it'll be Wednesday or Thursday, but before Christmas break, we'll test. All right? Good luck.